All right. Hi, everyone. I'm Brendan, and welcome to the RSK Community Call for July. We'll just wait for another few seconds for everyone tuning into the live stream to, join, and we'll begin very soon. While we're waiting, I'd like to invite everyone to take a look at two of the places where our community is active. So one is on Slack. If you go to developers.rsk.co/Slack, you'll be able to join a Slack community, which is where you can ask a lot of questions and interact with the rest of the RSK community, including the topics discussed in this call. The other place that everyone can join in the conversation on is on research.rsk.dev. This is not a chat group, it's more of a forum, and it's also got a more research focus to it, as the name implies. All right, I think we've got people joining already, so let's begin. All right, so RSK IP stands for RSK Improvement Proposals. You can go check them out at our GitHub repo there. And this is the agenda for today. So first off, we'll be talking about the Iris hard fork, followed up by 3 RSK IPs that are in the Iris hard fork. And then we'll also talk about a quick recap of the RSK IP process, which was discussed in the previous community call. And finally, we'll also talk about one more RSK IP before ending the session with some Q&A. So let's begin. Okay, so for those of you just joining us, I'll repeat one more time. To join in the conversation, please join developers.rsk.co/Slack and go to the Research and Innovation channel, and you'll be able to ask our research team any questions you like about RSK IPs. The other way to get in touch with us is research.rsk.dev, and we strongly encourage you, community members, to propose your own RSK IPs and discuss existing ones on that forum. All right, Adrian, would you like to?
Yeah, thanks, Brendan, and hi, everyone. We've been talking about Iris for several months, and with the release now ready to be made public and about to start with the rollout, we believe it's a good opportunity to refresh some of the concepts and features that are included in this release. So that's the idea of these first minutes of the presentation. So first of all, Iris, as you probably know, it's a network upgrade or a hard fork, as it's usually called. And a hard fork is a set of changes to the underlying protocol, right? To the underlying RSK protocol, of course, in our case. And those changes create new rules to improve the platform. And these new rules are coded into the RSK reference client, which is RSKJ. And of course, since the protocol rules change, all of the nodes in the network need to be updated. Otherwise, the nodes that are not updated will basically remain on an old change with the previous rules. So everyone running an RSK node instance, whether it's a testnet node or a mainnet node, you need to be sure you update it before Iris is activated. In this case, this new version does not require any special consideration apart from updating your node in mainnet or in testnet. So upgrading to Iris is a super easy task that requires only a few minutes of your time. So when is this activation happening? So the blocks that are defined for Iris activation are block 3,614,800 for mainnet. That's expected to happen around August 19th, depending, of course, on the variables of the network, of course, like block time, but it should happen around that date and on that particular block. In the case of testnet, it will happen a couple of weeks before, around the 4th of August, on block number 2,060,500. This new version of RSKJ is not yet available. There is a release candidate already published for testing purposes, but the final version with these blocks and the block activation that I've just mentioned will be most probably available next Monday. So there will be a few weeks for everyone to update their nodes before Iris is activated. So what's included in Iris? Again, this is something that has been in discussions for a long time, but as an overview, there are 18 RSK IPs included in Iris, so it's quite a big upgrade. All of these RSK IPs can be found in meta RSK IPs, as we call it, with this RSK IP 187. That it's, as I said, an index to all the consensus changes that are individually described in the RSK IPs repository. RSKJ Iris 3.0, which is the tag name for this upcoming version, also contains non-consensus improvements. There are several enhancements to the client itself that they are non-consensus changes. That these are mostly compatibility fixes at the JSON RPC interface, performance enhancements of the node, Java 11 support, among other things. You can check each of the pull requests under this under the Iris milestone in GitHub. Everything is there for anyone who wants to check all the changes individually. So regarding like the scope of Iris, it's a quite diverse hard fork with changes at the RSK virtual machine level, for example, with the inclusion of the Blake 2 compression function, which is a precompiled contract, and it's described in RSK IP 153. Some security enhancements in block mining that are part of a wider set of changes that we are calling fork-aware merge mining, but many of those will be proposed for future upgrades. Iris contains one of these changes, which is BTC RSK timestamp linking, and described in RSK IP 179, if I'm not wrong. But most of the consensus changes are improvements to the two-way peg, which you probably already know is the bridge between Bitcoin and RSK, by which the users can convert their Bitcoins into smart Bitcoins and RBTC, as you know, and the other way around. This set of improvements in the two-way peg mainly fall into two big categories. One of them is user experience improvements, which is something that the community has been asking for some time, since users using the native bridge are generally facing some challenges when they need to convert BTC into RBTC. And then some of the changes are security related, and that is something that we are constantly looking to improve, especially as we see more Bitcoins coming into RSK and being locked into the two-way peg. Again, all Iris consensus changes are openly described in the RSK IPs repository. Of course, it could take hours to go through each of them during the call, but we will refresh today, as Brendan said before, the most relevant changes to the two-way peg. A couple of them about user experience, and one relevant about security that Sergio will describe later. So that's like a general overview before we jump into these specific RSK IPs. But finally, wanna share some words of thanks to the whole RSK community that got engaged into this effort. It took several months of work. We started discussions about Iris in early 2020, if I'm not wrong. Well, there was a huge development effort on the RSKG client that has been done mostly by teams in IOB Labs, but there have been also really significant contributions and ideas and feedback coming from many members of the RSK community, such as Money on Chain, CoinSpect, Sovereign, to name a few. And there were even code contributions from developers through the Gitcoin platform. So thanks so much, everyone, and special thanks to the development teams behind this achievement. Right. So going into some of these changes, as I said before, the first one we wanted to refresh, because these are all things that have been in discussions for months, as I said before. But probably these ones are the, from my point of view, one of the most relevant ones. The first one is RSKIP 170, which has a title that you can see there. That's Pegin to a user-defined RSK address. This is these are our changes to the Pegin protocol. It's quite simple, yet it enables a much better Pegin experience. So the goal is of this consensus change is to basically allow users to specify any address in RSK, that being an externally owned account or a contract, where the RBTC will be delivered when doing a Pegin transaction, right? So you probably know that currently the destination address when doing a Pegin transaction is related to the basically to the transaction and the account that originally sends the Bitcoin. So there is no way for a user to specifically decide what address the RBTC will be delivered. And this is probably making the process a bit cumbersome from the user experience perspective. So the idea of this RSKIP is, well, basically that enable a transaction to specify, a Bitcoin transaction to specify where the RBTC will be delivered. And this is done by including an output with an op-return opcode and certain payload. Everything is described in the RSKIP, but that's where it's specified the address where the RBTC are delivered. Of course, this requires, I mean, this enables the developer to build solutions that use this feature. For example, any wallet wanted to provide this feature needs to basically implement this new feature, but it's backwards compatible. So no change is needed to so that the tools currently implementing this feature can keep working the same way that they are working today. There are already some teams working on solutions that use this feature. For example, the screenshot you can see there, the image on the slide, it's a work being done by people in IOB Labs together with the people in True in Colombia, where you can see that's a very easy to use interface where I don't think it's something that it's very clear in the image, but basically on step 3, the user can type the address of where they will be receiving the RBTC. So it simplifies the experience quite a lot. So that's really, really good. So that's very briefly about RSKIP 170. And there is another RSKIP, pretty simple, but I think it's good to share, which is this one, RSKIP 219, which is a reduction to the minimum Pegin and Pegout values. So basically in Iris, the minimums are reduced to half of the current values. So the Pegin minimum, which is currently 0.01 BTC, it's cut in half, it becomes 0.005. and similar happens to the payout minimum value, that it changes from 0.008 to 0.004. So that the only thing to maybe note here is that there is so since payout fees are generally significant, and there is a reason for this to happen that requires a longer explanation, but the important thing is that they can represent a significant percentage of the amounts that are being sent in the payout transaction. There is a new rule that is being introduced by which a payout will not be processed if the fees of the payout transaction represent more than 20% of the total payout value. So that's the additional rule that probably becomes relevant now that the payout minimum has been reduced. But the good thing is that, yeah, that the payout and Pegin minimum fees are now cut in half. So some ideas about reducing this even more require some additional changes that are not coming in Iris. So hopefully we can see lower values in future network upgrades. So that's basically it about RSK IP 219.
All right. Okay. I guess I will hand it now. Hey all. I will be talking about the Flyover protocol, and I just was talking about how we are decreasing the minimums for Pegin. And another aspect that has been requested several times is to get RBTC faster than having to wait 100 blocks on Bitcoin. So with this protocol, we are offering an opportunity to the market to create the possibility of bridging BTC and converting to RBTC with just at least one Bitcoin block, and making it in a way completely decentralized. And the idea behind this is to have a Solidity contract that is going to enable the liquidity providers that are going to offer their RBTC to the users for them to send BTC to a custom federation address and receiving the RBTC on RSK on the address they decide to, with just one confirmation. This is opening a new market for liquidity providers and at the same time offering users another alternative besides the regular Pegin. For Iris, we are including, in this case, changes on the bridge to make this possible, aiming to register new UTXOs for the bridge that are not going into the regular federation, but derived federation address that is including certain metadata on the Bitcoin script that is only unique, for the operation that is being executed. And this is without losing the security behind the PowPeg federation, which includes the HSM, the ERP, and the rest of the known functionalities. This whole operation is not only based on the bridge, but also, as mentioned, it's going to be used. It's using a Solidity contract that is under development and can be evolved as soon as the community requires it or the business requires it. It requires development the decentralized application that at this moment we are working with partners and community members to think on possible solutions for this. And definitely requires the liquidity providers to get involved and offering their funds. This whole operation, as a summary, is going to be secured by the PowPeg Federation, but it's not going to be the regular federation. This is going to be a unique address per operation, and the idea behind this is to avoid mixing the operations. We don't have yet the Solidity contracts finished. This is something that is under development, but we wanted to have the consensus changes on Iris so we can later evolve the Solidity contracts and have the derivation, the decentralized application ready. I think that's pretty much it.
Jose, may
Yes.
I add something?
Sure.
One important thing is that anyone can develop a Solidity contract to use this feature. So we are proposing one particular business models where Solidity, where liquidity providers get a fee, receive a fee for doing this work. But if you want to create another parallel contract, you can use this feature because it's embedded in the consensus of the platform.
Yeah, the bridge is not constricting this in any way. It simply expects to receive a Bitcoin transaction from any address that should be a contract, and that's the only validation it takes. So yeah, Sergio mentions, it's not that we are restricting the operation to the Solidity contract we develop. We are creating like the base foundations and offering for anyone to expand on it or create a completely different one. Thanks, Sergio.
All right. Yeah, so next up we have Sergio, who will be talking about the RSKIP process and RSKIP 201. And I believe you have your own slides, right? So if you want to take over the screen share right now, that would be great.
Yes.
And while that's happening, I'd just like to sort of remind everyone to join in the conversation on our open Slack or our research forum. The URLs should be on the slides at the end that you'll see at the end as well. Okay, Sergio.
Do you see the screen?
Yes, yes.
Okay, let's go ahead.
Thank you.
So the RSK Improvement Proposals is a process and a repository where you can find all the past proposals and you can make proposals, and there is a process for the community to discuss these proposals until they get included in a hard forking release of the protocol. So we started doing this in 2016. There are approximately 144 proposals published. So there has been a lot of work from different members of the community and a lot of work from the reviewers of these proposals to make sure they are up to certain standards. There are 20 proposals that have been abandoned or are still incomplete, and okay, we encourage everyone that started them to finish them. And 40 proposals have been adopted and have been activated in the past, plus the proposals that are activated in Iris. So there, you see, there has been a lot of work. So the RSKIP reviewers or editors are these 6 people. Diego, me, Julian, Shrimoy, Javier, and Raul, and we tend to split the proposals into, you know, whoever can take has the time to review it. So if you submit your proposal, any of these people can help you with the review process. Of course, if any of these people has a proposal himself, he cannot be his own reviewer. There must be some other reviewer. So this is something that I explained in the previous community call. I will just review it quickly. There is a workflow for how these documents change their state. Essentially, they start as a draft. There's a lot of stages that I will talk about later about how the community will accept or refuse an RSKIP proposal. But once it is accepted, it will be waiting for the hard fork, which is so it will be in a fork pending state until it has been adopted, which means that it has been activated in the platform. Also, RSKIPs can also involve some things that are not part of consensus, like if you want to create an RSKIP to change the JSON RPC interface, which also must be standardized. Well, that will go directly from accepted and adopted when it's coded and released. So these are all the steps of the proposed flow where you can get community feedback and you could get from your idea to the RSKIP accepted by the community. So first, you don't have to scare about all this. This is easy. If you follow these steps, then you can get your RSKIP accepted. In the past, when the community was much smaller, some of these steps were performed simultaneously, but we really want now to perform each step separately so that we can do this orderly and, of course, in an auditable fashion. So it starts with an idea, and then we suggest you discuss this idea with your team members or in the research forum, because many ideas have already been discussed or have already been discussed in other crypto economies like Ethereum. So many people in this community knows all Ethereum proposals very well. So you can get help and you can get to find if your proposal is new or represents something very similar to an existing one. Then we encourage you to find collaborators, people that know all the other proposals, and so they can help you find what's particular about your proposal, what makes that proposal different from the previous one. Then you should write a proposal following the guidelines that we'll talk more about later, or co-write it if there are many authors. And you will create a pull request in the GitHub repository I mentioned before. Once you create a pull request, you immediately get a number. So you can start referring to the RSKIP by its number. So you submit again, you push the new document with the correct number. One of the reviewers will be chosen to review it, and the reviewer will try to make sure that your document is precise and it's accurate and conforms to the standard. The reviewer may give you some hints about the proposal itself, but it will never block your proposal because he has a different opinion. He or she just want to make sure that you follow the rules and the proposal is clear enough for the community to discuss it. So you will probably correct a few things and send it back, and then the RSKIP will be merged. So now that you have your RSKIP merged, you have to open it to the community to see it, because if not, it just will stay there in a repository without any attention. So you should add a link to this document pointing to a place where community can discuss. This place historically has been the research.rsk.dev forum. And you will create a thread in this forum where you will explain it and obviously defend it. So people will have different opinions, people will criticize it, and so you have to be there to defend it. If you abandon the RSKIP, probably no one will take care of it. So you have to champion it, you have to defend it, and you have to give good arguments in favor of this RSKIP. A couple times a year, with exception with Iris, which kind of was delayed, you will receive from the leader of the development team, which is Adrian, a call for proposals to be included in the next upgrade. This is going to be published in the forum, but also in communication channels. So that's the moment where you say, okay, I want this RSKIP to be to propose it for the next upgrade. If you don't do that, if you just don't try to add this RSKIP to the upgrade, you may not see it coming. So what Adrian will do, it will read all the discussions and it will pick all the RSKIP that are non-controversial. Like if an RSKIP has a lot of opposition, it will just not be picked. The ones that are picked are the ones that are essentially somehow there is a consensus about that. There may be some differences, but essentially there must be some kind of technical consensus that is good. So you will be invited to defend this in a community call if there is some disagreement. So you have to be prepared to make a 10-minute presentation of it. And probably in the following community call, there will be some kind of voting or making sure that everyone has agreed to merge it in the next community call, and sorry, in the next release. And then all the steps for the release happen, which are many other steps like testing, coding, AlphaNet testing, testnet testing, or there are many stages that happen afterwards, but these are essentially the things that happen before. So there may be cases where even if your RSKIP goes through all these stages, it may not be included in the next hard fork, which is if you don't provide the code, so you expect the core developers to develop it, and the core developers do not have time because your proposed change may take 5 months, and then the next hard fork is only 3 months, and so that might make it to skip hard fork because we have limited resources, or the core team has limited resources. Okay, so. So what are these sections of the document? I'm going to go quickly over this. There is a preamble that has some metadata about this RSKIP, the author, the complexity. Then you have an abstract where you will write a short description of the technical issue being addressed. Then you write a motivation where you can explain where this motivate, where the why do you want to do this? You may be developing a protocol that cannot be secure because you need something from the platform. You may be developing a wallet which you bump into a problem. You would be great to have a feature. So you explain all the context where this feature or this requirement has appeared, and then you write the specification, which should be as short as possible, as technical, as formal as possible. You can put equations, you can put math, you can put pseudocode, anything, but this have to be short to make sure that it's correctly specified. And then you have to write the rationale, which is all the design decisions that you took to reach that point, that's a specification, but also all the designs you dropped because they had some flaws. And here you have to include, this very good if you include all the reference to prior RSKIP or Ethereum proposals that are competing with your proposal. That is important for the community to be able to really evaluate one. So next you write the compatibility issues that you found, the implementation, that at this point, because we really want more contribution from the community, we are not asking for code to be delivered beforehand. If you do it, then great. If you not, then the core developers will do. But it's good if you develop the code, because you will probably find problems that you could never have thought before. And then you can provide test cases which can be handmade, or they can be automated if you have coded. Finally, there is a copyright waiver, so that everything you put in this document is public domain. It will not be encumbered by patents or by copyright of any kind. So this is a donation to the world. In the preamble, this is an example RSKIP. You have the number, the title, the time it was created, if it was created in some other format before it's been published in the RSKIP, the author, the purpose, this is classified in the RSKIP 0. You can see the different purposes are security, privacy, fairness, scalability, and I think a couple more. The layer, it will impact the complexity, which is your interpretation, your estimation of how complex this is. It can be 1, 2, or 3, and the status that I talked before. And I think that's all. Yeah.
All right, awesome. Yeah, so just wanted to point out that the next thing that we'll be talking about is the RSKIP 201. And Sergio, you have an article out on Medium. We'll post that in the comments in the live stream now. But we'll also, do you have a slide deck for this?
Yes.
Okay. Why don't you go ahead and share that?
Yeah.
All right, and while we're waiting, please join the conversation on our Slack or our research forum. I'm going to say that every time.
Okay, so this presentation is about RSKIP 201, the time-locked emergency multisignature. So first, definition: a time-locked emergency multisig is a backup method to access the funds of the RSK2A peg that is only activated after 1 year of continued external attack. These are the 3 cases that we identified. One is a continued DOS attack against the RSK mining network, like every single miner is attacked or decides not to participate anymore in the RSK. And this is very, very low risk. The next one is a continuous DOS attack against the majority of the signatories. Again, this is very, very low risk that this could happen for a year. And the third one, which has some low risk, but still has risk, is the seizure of the majority of the POW HSM devices. So what if someone wants to take control of the devices to get a ransom, or malicious governments, or some kind of malicious group? And the most important reason is if there is some internal bug or vulnerability that breaks all the devices, the proof of work HSM devices at the same time. So I think that the last one is the main reason that we included this emergency multisig in the beginning when we designed the PO HSM. Okay, so how does this new Bitcoin script for the PowPeg address looks like? So it has two execution paths. The first one, which is the normal one, is where you find the public keys of the 12 signatories. And the emergency one is the one below that you will see that there is an opcode called op check sequence verify that executes or limits to it's a relative time lock from the time the previous transaction was included in the blockchain to the time this transaction, a transaction that spends this output could be included in the Bitcoin blockchain. So there you will find at this point there's a mistake here in the slide, 4 public keys of the emergency signatories. Okay, and last you have a check multisig that works for both paths. So a 1 year time lock. I think this is a very conservative value. It gives time to diagnose if there's a problem. It gives enough time to diagnose, coordinate with the community actions, and perform network upgrades with a good buffer. As an example, the Liquid blockchain accidentally activated a time lock in June last year due to a bug. And this was because Liquid used a short time lock of only 2015 blocks, like 2 weeks. So they had an accidental activation. They had to manually return the funds to their federation. So we don't want to bump into this problem. So what would signatories do in case of an emergency? Okay, so this is to be decided by the community, but my interpretation of what I've been discussed is that there are essentially 2 possibilities. And we are talking about a catastrophe, right? This is something that should never happen, but it's good that we discuss it. So if RSKIP is live, then the community would coordinate a network upgrade to establish a new PowPeg, so a new set of signatories. That requires a hard fork, or no, it could be, it probably requires a hard fork at that time. And then this set of signatories will resend the Bitcoins to the peg as a donation. So this is a feature that is enabling Iris. You can send funds back to the federation without distributing them to any user on RSK. So this works as a donation to the peg. So if anything happens with your funds, you can always return them to the protocol. And if the case that RSK is halted, like it's not working anymore, we could either restart RSK to make sure that all contracts can give back the funds to their rightful owners, or if RSK cannot be restarted, then we still can return to the rightful owners all the funds based on proof of ownership of the funds, right? The private keys that the user have. The only problem in that particular case would be the unknown contracts, like public contracts, that would need to be analyzed by case by case. So a brief history of why I'm talking now about emergency while the emergency signature was decided a long time ago. So in the first quarter of 2020, there were a series of community discussions about the PowPeg. There was feedback from the community and from security auditors, and there were many issues raised because at that point the technology was not ready, so there was nothing built. So there was a lot of questions about how reliable this technology would be. So the consensus achieved was that we would do the PowPeg, which removes any human capability of having control of the private keys. We would put that with an emerging multi-signature to make sure that if something happened to this new hardware that was not built yet, then we could still recover the funds. In the following month, there was a huge design and development effort. And in the final December 2020, the first POW HSM were delivered and installed. In this year, the development of the emergency multi-signature started, which impacts the bridge contract. And in the second quarter of this year, there has been security audits, external security audits, internal security audits, AlphaNet testing, and the Iris release, which is ready now. So a lot of effort has occurred since the decision was made to the time the software is delivered. And we hope that in the future, there is not so much time because, of course, things can happen meanwhile. So what are the concerns? What are the risks that motivated the use of the emergency multisignature? Well, firmware bugs, like human errors that can make the device break and do not respond anymore. Flash memory failures, because these devices have a limit in the amount of write cycles that can perform to flash memory. So we were worried that the devices could burn out, all the systems could fail all that at the same time. There can be board components failure, like some other components that are not the secure element chip, but surround the secure element chip, like power. There could be power glitches that burn the processor or something. And then, of course, that I talked about censorships, seizures, and ransom demands, right? These were the risks identified. So who will be the private key holders? This was also discussed last year. So one key is given to IOB Labs based on these proven past contributions to the expansion and security of the RSK platform. One key was given to Adrian Edelman because he's the leader of the core development team, and he has been like how many years? A lot of years working on this code. So he's very well respected. Jameson Lobb, which you probably know, he's a renowned Bitcoin contributor. He's the CTO of the CASA company, which specializes in security systems for Bitcoin. And then a fourth key was offered to the most relevant projects on the community, which currently, based on the number of transactions, are Sovereign and Money Chain. And Money Chain accepted the responsibility, so they are holding one additional key. So this would be a threshold of 3 out of 4 signatures. So what can happen in the future with the emergency signature? Because there's some community members who said that they would prefer not to have the emergency signature once the devices are proven to be safe, right? To work as suspected. So a lot of things we can do to remove it or to improve it. We can increase the number of signatories from 4 to 12. This would reduce ransom risks. We can increase the time lock from 1 year to 10 years, for instance. We can use features that are coming in Bitcoin Taproot upgrade to improve our multi-signature, our PowPeg multi-signature, so we don't need the emergency signature. For instance, MAST, Merkleized Abstract Signatory, allows you to have a larger set of emergency signatories or pegnatories. And this one was proposed by Diego and again proposed by John Light a few weeks ago to have this second set of the signatories to become also pegnatories. So to create a second emergency PowPeg running the same devices so that we never lower the level of security, even in case of compromise or seizure of the POW HSM. And then we could use a feature that's not available in Bitcoin, but could come in the future, which are covenants, to create virtual outputs. This was proposed by Ed and Jago from Sovereign. The idea is that we can create a snapshot of the whole system that are embedded in a single Bitcoin output. And these snapshots allowed, in the case of catastrophe, like RSK is no longer functioning, then it would allow the automatic return of the funds to the rightful owners without any involvement. This is, and all the information will be concentrated in a single output. You can read in the article how this is achieved. Then, having Schnorr signatures, we could allow a larger number of pegnatories, like from 12, we could go to 100 and use threshold signatures. And maybe if we had that number of pegnatories, then we wouldn't need the emergency signature. We could discuss that. And also having multiple HSMs, that also reduce the risk of the devices being bricked, as long as they have kind of different source code, different implementation of the protocol, then we eliminate a single point of failure. So these emergency multi-signatures can evolve, probably will evolve, And I expect you to participate in discussing what is the best for RSK to become the most secure peg in this planet. Okay, that's it. Thank you. I don't know if there are questions or there's time for questions later.
All right, thanks, Sergio. I guess now it's time for us to perhaps open up the floor to Q&A and comments from the community. I know there's been a lot to take in regarding all the RSK IPs that have been proposed. So who would like to start? We have, sure. Okay, so John Light, if I see you already on stage, if you'd like to unmute yourself, I know that you have some questions or comments.
Hello.
Hi. Hello. Floor is yours.
Thank you all for putting together this call. Looking forward to the Iris hard fork. So the emergency multisig is a kind of a sticking point for me. I've been having conversations with other folks who are building an RSK ecosystem or have funds in the PowPeg, and at least among the people that I talk to, there are more folks who are concerned about the potential degradation to the security of the peg by adding this emergency multisig than there are people who are think that the concerns that motivated having this emergency multisig are kind of outweigh those risks. And so given that the Iris hard fork is so close, it might not be appropriate to delay it any further. But I'm wondering how soon after the Iris hard fork we would be ready to take a second look at the emergency multisig and maybe not get rid of it, but augment it using some of the hardening techniques that you just shared, Sergio. We could start with just expanding the number of signatories on the multisig so that it goes beyond the 3 of 4 that there already are. But those improvements could also include, like you said, actually securing those keys using PowHSM devices or some other kind of secure elements.
I've discussed with Adrian and with the core developers, and I think that we have an idea that the next upgrade could be focused on security, a focus on some features that have been left out of Iris regarding batching of payload transactions in the breach, which also affects security. So I think the answer is yes. We can try to narrow the scope of the next hard forks to put security first, and if that means adding more signatories or switching to a PowPeg set of emergency signatories, then I'm for it. So I always put security first. I don't know if Adrian, you agree with this?
Yeah, absolutely. One of the things we've been discussing also lately, especially after so many months of development with Iris, is that most probably next upgrade should happen like in a few months. So we can, and with the idea of also start considering some of these improvements, also coming from some of the concerns from the community, like the ones that you are mentioning, John. But just to add something is, we believe that next upgrade should happen in a kind of short time frame of a few months, not that long as happened with Iris that took almost 1 year or something like that.
I would like to add that this doesn't mean that we won't follow the procedures that I mentioned before. So let's start working right now about these ideas of improving the emergency signature. Let's write the RSKIP and let's put that on the hands of the community to evaluate. Because then if times is going to be shorter, then it's going to be shorter for everyone. From production of the RSKIP, testing, everything would have to move faster. So yeah, let's do it.
Understood. Thank you, guys. One quick follow-up question, if you all know the answer to this question. So I know that Jameson Lopp is based in the United States. What jurisdiction do the other 3 emergency keys fall under?
Well, let's see. One is Uruguay. The other is, I suppose, Argentina. And the other, let's see, Jameson Lopp is in the US, and IUB Labs would be Gibraltar. Okay, this would be the 4th jurisdiction, if I'm correct.
Okay. Yeah, something good for the community to know when they're thinking about. Thank you.
All right. So I've just checked the community Slack. There've been no questions there, and I've also seen the comments on the different live streams. Okay, so I think there is a concern from Mariano. He says he's freaked out by the title that contains hard fork and the word emergency. So maybe Adrian, would you like to allay his concerns?
Yeah, absolutely, and I think I mean it's a valid concern that Mariano brings, but first of all, there is nothing to worry about, and Mariano, your RBTC are absolutely safe. This is a planned hard fork. Basically, that means it's consensus changes that are brought to the platform to improve its features. It's nothing like to worry about, or it's nothing done as an emergency to fix any vulnerability, right? So these are improvements similar to the ones we've mentioned, and as we said before, they are all listed and public for you to review. But I understand that probably the name hard fork can be sometimes a bit scary. That's why we usually use network upgrade, which it's probably more friendly. But replying to Mariano's question, this is not something to worry about. It's basically part of the process of any platform, not only RSK, but any other. Regarding, I think he mentioned the word emergency, probably related to what Sergio was explaining before. This is and some of the concerns that Sean brought. This is also an inclusion in the consensus changes to have a contingency plan in case something could eventually go wrong, but it's not something that it's happening, and we don't expect that to be used, as Sergio said before. So in short, there is nothing to worry about, and you can keep your RBTC safely.
Awesome. Yeah, and follow-up question from Mariano is whether the user needs to do anything. And the answer is no, you don't need to do anything unless you're running an RSKJ node. In that case, then just update to the new version, and then everything continues as normal. If you're using a wallet, it's still the same RBTC, no change. Is that right?
Yeah, absolutely. Yes. As you said, the important thing is that node operators do upgrade before activation happens. around the 19th of August, as I mentioned before. It's always good to do that before to check everything is working fine. But if you're not running a node yourself, there is nothing you need to do.
Mm-hmm. One thing that I want to point out that generally people that have worked in computer security get a little bit paranoid, and they plan for the worst. They consider the most important. They prioritize security issues by their most important, or the risk by their frequency, but they also plan for the worst. And this is planning for the catastrophe. So it's kind of a hacker mentality or computer security mentality.
Well put, well put. Yeah, and I think also in the comments from Alan, we have, I think something that maybe sums it up. It's like there is no security flaw. It's just a mechanism to handle possible failure. And following on from Sergio's comment, it's just, a very, very unlikely failure, but catering to the unlikely situation is still important. Let's see if there are any more questions. Okay, Mariano is happy with our answer. Excellent. Okay, great. And also a comment from Maxi Carjuza. So yeah, thank you very much for your comment. We look forward to growing together with the community and with all of our partners as well. All right. I guess that's it for today. Let me just wrap up. Okay, so let's continue this conversation. This call is just a live synchronous event. You can watch it again on YouTube and all of the other live streams. It just automatically converts into a regular YouTube video. So if you want to ask us more questions or speak with the rest of the community, then go to developers.rsk.co/Slack and then and check out all the channels there. For those of you here, the most relevant one would be the Research and Innovation channel. We also have a forum, which you can join at research.rsk.dev. And we would strongly encourage everyone in the community, even if you're a RSK user or if you're a partner building a product on RSK, please look through the existing RSK IPs and discuss them with us. And also, if you're up to it, propose your own improvements as well. We welcome all suggestions. And we have a full process to handle RSK IPs, as Sergio has detailed earlier on in this call. And finally, just to wrap up, we do have these community calls regularly. So the next one will be soon, and the date has not quite been set yet or been confirmed yet. So please go to that link that you have on the screen right now and put in what you'd like to discuss. Anything that came out in Iris in that big list that Adrian showed us earlier on. We haven't covered all of it. We just covered a small subset, this stuff that I guess was the most important. But anything is up for discussion. And I think that's all. Okay, so thank you very much for joining. It's been a pleasure. Please continue the conversation. Ciao.
Thank you all. Bye-bye.